Hi, so this video demonstrates my Python implementation for the data visualization research coursework. And in the first code snippet, I imported the libraries like pandas, matplotlib, and Python pathlib. Pandas was used for data loading, cleaning, filtering, and annotation, and matplotlib was used to create the line and bar charts. I also imported the path from pathlib to check whether the files are saved correctly. And in the next code snippet, I loaded the dataset European Airport Traffic.csv. Here the dataset was loaded successfully. And in the next code snippet, I after the loading the dataset, I inspected the original values, names, and data types using diff.info. And in the next code snippet, uh, the the I standardized the column names. I converted all names into lowercase and removed spaces, replaced spaces with underscores. For example, time period. Before it was capital, and I changed it into small time, small time or ad, small time period. This made code easier to read and reduced the risk of column names error later in analysis. And then I checked the unique values in important categorical columns including TRA, MEAS, transport coverage. This showed the available passenger measurement types such as passenger on boards, arrivals, departures, passenger carried. This step helped select the correct record for analysis. And in the next code snippet, the dataset was when filtered to keep records where TRA-COV equals to total and TRA-MEAS equals pass PRD. This means the analysis used total transport coverage and passengers on board. This avoids mixing different passengers measures such as arrivals, departures, carried passengers, which could lead to double counting. In this step, the time period column was converted into date time format. OBS value was converted into a numerical passenger. The code also checked for missing dates, missing passengers, missing values, and negative passenger values. The output showed 0 missing dates uh, and values and 0 negative values, so imputation was needed. Then in the next code snippet, the data set was then used to create a new year and month column. Dataset was filtered to include only the years 2022, 2023, which matches the visualization requirement. And then after I check the missing value check, then the result showed 0 missing values, showed some 0 missing values. This confirms that dataset was ready for acceptation and visualization. And then next, check out the schedule column. The output showed that schedule column category was TOT and the type schedule was total. These confirms the dataset was already using total schedule records, so no additional schedule filter was required here. And then in the next code snippet, I removed some allocated rows such as European Union totals. These rows were removed because they represent combined totals, not individual reporting entities. Removing them avoids double counting. After this the step final analysis dataset contained 1669 rows, and in this code snippet the data grouped the data by geopolitical entity reporting and calculated the total passengers for each reporting entity. The results were stored in descending order, and the top 10 were uh, displayed here. Then the results were sorted in descending order, and the highest passenger volume followed by the Germany, Turkey, France, Italy. And in the next code snippet, then I grouped the data by year to calculate year-to-year passenger totals. The results showed the passenger volume increased from 469.6 million in 2020 to 638.7 million in 2021. Then to 1.324 billion in 2022, 1.575 billion in 2023. The largest percentage increase occurred between 2021 and 2022, showing the strongest recovery phase. And in the next code snippet, then I calculated by grouping the clean data. The month column, these created 48 monthly records from January 2022 to December 2023. This table was used to create monthly passenger line chart. The first visualization in the line chart was showing monthly passenger totals from 2022 to 2023. These passenger values were converted into millions to make the chart easier to read. The chart shows a sharp drop in early 2020 reflecting COVID-19 disruption, followed by recovery 2021, stronger growth in 2022, and continued every recovery in 2023. The chart was saved passenger totals 2020-2023.png. The second visualization is a bar chart showing the top 10 reporting entities by total passenger volume. The passenger volumes were also shown in millions. This chart makes it easy to compare passenger volumes and across countries. Spain was the leading reporting entity. Spain was leading reporting entity, followed by the Germany, Turkey, and the chart was saved as top 10 airport passenger.png. Saved PNG files. The notebook then checks whether both required PNG files were successfully saved. The output confirms that line chart and bar chart were saved correctly, which satisfies the assessment requirement, I would say. And then finally, the notebook prints a report summary. It shows the dataset used, the original dataset shape, the final analysis dataset shape, the monthly totals, the top 10 table shows, shape and the name, the requirements, output files. These confirms that the notebook runs as complete reproducible analysis. In the conclusion, this notebook meets the reset requirements by loading dataset from working directory, cleaning, preparing the data, printing the top 10 report entities. The report then explains the cleaning process, research questions, visualization findings, conclusion limitations, references, and AI use declaration. Thank you.